Hey Ramblers! This video covers chapter 11.8 in our textbook and deals with Hero's formula. Now we've talked about a lot of area formulas for triangles in this chapter. We reintroduced you to a formula you've probably known since grade school, 1/2 base times height. But then we also talked about another couple formulas like the area of a right triangle was 1/2 leg 1 times leg 2, or the area of a regular triangle could be thought of as side squared root 3 over 4, or 1/2 apothem times perimeter. Tonight we're going to introduce you to another formula that can be used on any kind of triangle. Doesn't have to be a right triangle, doesn't have to be a regular triangle. And it's based upon the side lengths. So there's a couple of side calculations that go into the formula, one called the semi-perimeter. And then we'll use that in this long square root, which generates the area of a triangle. Now the proof of it, or the derivation of the formula, requires something called the law of cosines, which is a little bit beyond the scope of this course, but you'll learn it in pre-calculus. So in the meantime, I'm just going to present the formula as something you'll have to memorize, but I think you'll find it really handy. So please pause often, take good notes, and thanks for watching. Hero's formula is a method of finding the area of a triangle that works for any triangle. Doesn't need to be a regular triangle, doesn't need to be a right triangle. It can be any old obtuse triangle or just a plain acute triangle. And it's based on the lengths of the sides. Now until now, we've had our standard formula 1/2 base times height. And no matter what kind of triangle I had, I could use this and I would be able to find the area of the triangle. But what if we don't know the height? Now you can find that using a system of equations, but there's another way that might be an easier way, and it's based on the side lengths. The convention for naming the sides is always little a is opposite a vertex that's usually called A. Little b is opposite a vertex labeled B, and little c would be opposite a vertex labeled C. Now Hero's formula is kind of a long derivation, but it involves a side calculation called the semi-perimeter. Now the semi-perimeter is just the perimeter, A plus B plus C divided by 2. So it's half the perimeter of the triangle. That semi-perimeter is called S. And S is entered into a long formula under a radical, which is the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus C. And all of that is under a radical. Now if we take a look at the area calculation, we can see that we get a semi-perimeter here of 16.08. That represents A plus B plus C. And you can imagine that these three added together, 10.26, 13.37, is going to be about 23.63. Add another 8.53, and we're up to around 32. So half of 32 would be about 16.08. Now, if we run that through our Hero's formula, taking the square root of those four products, we get 43.75. And that is the same area that we got using 1/2 base times height. So you might wonder, why do we even have to use all this? Well, it's all based on the information. If you're given a base and a height, then by all means, use 1/2 base times height. But if all you know is the 3 side lengths, then this is a pretty good formula. And as you can see, no matter how I manipulate this triangle, the old formula that we've known since grade school and Hero's formula always remain the same. Okay, Ramblers, thanks for watching, and I hope this helps. We talked about another means of finding the area of a triangle called Hero's formula. Now, Hero's formula was based on the lengths of the sides, and so it was important to recognize those in the formula. And the first component of the formula is the semi-perimeter. And the semi-perimeter is the length of the three sides divided by 2. So it equals A plus B plus C over 2. Then each one of the sides is subtracted from the semi-perimeter under a square root. So the area equals the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. It's important to remember that Hero's formula can be used for finding the area of any triangle, and it's very helpful when all you know are the sides. So it really depends on the information you're given. Okay, Ramblers, hope this helps. Number 8 on page 552. It's a good chance to use Hero's formula and also to address this theme that keeps coming up in this chapter of finding the area and then using it to find a dimension. So they ask us to find the measures of the three altitudes of this triangle. And the trick is they want us to use Hero's formula to find the area and then 1/2 base times height to find each altitude. All right, well, let's give it a shot. I know that with Hero's formula, I'm going to need to find the semi-perimeter S. And that just equals 13 plus 14 plus 15. That's the semi-perimeter. I'm sorry, that's the perimeter divided by 2. That will give us the semi-perimeter. I really advise you don't take shortcuts with Hero's formula. It's too easy to make a mistake. So when I calculate the semi-perimeter, I get 21. Now, all of that goes into the big radical, which will equal the area when I get the final answer. And so that's 21 times 21 minus A, which I'll call 13, 21 minus B, which I'll call 14, times 21 minus C, which I'll call 15. And when I've calculated all those, I get a big number under the radical of 7,056. Now this might be a good time to grab the calculator, but having taught as long as I have, I recognize that I could probably try and put 144 into that. And when I do, I get the square root of 144, oddly enough, times the square root of 49. Well, the fact that these are both perfect squares tell me I'm going to get a nice whole number, nice integer for you, which I know all of you like, and so this equals just 84. So how does that help me find the altitudes? Well, let's take one of them. I'm going to drop the altitude from that vertex at the top, and if I call it, let's say, x, then I know area equals 1/2 base times height. Well, I used Hero's formula to calculate the area, and I know that that's 84. So 84 equals 1/2 base, well, I know the base in this situation is 15, times that height I'm calling x. So when I solve this, I multiply both sides by 2, which gives me 168, divide by 15, and that's going to equal this altitude x. If I reduce that, I get 56 over 5, and that's my first altitude. Now, I'm going to find the other two in a very similar fashion. So the next one I'm going to look at is the altitude that runs from the lower left up to 14. And by very similar calculation, I know that 84 will equal 1/2. This time my base will be 14 times, let's call this one y. And so if I do the same calculation again, I'll get 168 over 14, and that's equal to y. Okay, 14 goes into 168, so I know that 12 equals y is my final answer there. And then to get the last of the three altitudes, I'll draw from the lower right, and I know that once again the area is still 84, and that's going to equal 1/2. The new base here is 13, and we'll call this last one z. So 168 over 13 is going to equal z. And so that gives me my last altitude that I need to find. Okay, Ramblers, one last caution, be really careful to go step by step with Hero's formula. It's way too easy to make a mistake. All right, Ramblers, thanks for watching. Hope this helps.